Hey, welcome to The Numbers Game. I'm Coach T, and today we'll be going over derivatives. We'll specifically be looking at applications of the quotient rule. Now, the quotient rule is used when trying to find the derivative of two terms being divided. So we'll go over the formula, and then we'll go through a few examples. Let's get started. Quotient rule is used to find the derivative of a function that includes division. So let's go over the quotient rule formula. It is the derivative of u over v, where u represents the numerator of our function and v represents the denominator, equals the derivative of u times v minus u times the derivative of v all over v squared. So let's take a look at this function. F of x equals x cubed over x squared minus 2. So let's use the quotient rule to solve for the derivative of this function. F prime of x equals the derivative of x cubed, 3x squared, times the denominator, x squared minus 2, minus the numerator, x cubed, times the derivative of the denominator, 2x. And then this is all over the denominator squared. So we've got x squared minus 2 all raised to 2. So this gives us our final answer. It can be simplified further, or we could leave the answer as is. So we were able to find that the derivative of our function equals 3x squared times x squared minus 2 minus x cubed times 2x all over x squared minus 2 raised to 2. So let's take a look at another example where we can apply the quotient rule to find the derivative. Let's look at the function f of x equals 4x squared plus 1 over x squared plus 1. So here we see that we have a numerator and a denominator. They're being divided, so we know to use the quotient rule. So let's use the formula to solve through the derivative. So we've got the derivative of the numerator giving us 8x times the denominator, x squared plus 1, minus the numerator, 4x squared plus 1, times the derivative of the denominator, which gives us 2x. This is all over the denominator squared, so that's x squared plus 1 raised to 2. Our final answer. Finally, let's take a look at a trig example. Let's take the derivative of function f of theta equals sine theta over cosine theta. So we'll use the quotient rule to solve for the derivative, and then we'll use what we know about our trig identities to simplify. Let's get started. So f prime of theta equals the derivative of sine theta, cosine theta, times our denominator, cosine theta, minus our numerator, sine theta, times the derivative of cosine theta, which gives us negative sine theta. This is all over our denominator squared. So that's cosine of theta squared. Simplifying, we get cosine theta times cosine theta, giving us cosine squared of theta. And then we've got minus sine theta times negative sine theta, which gives us plus sine squared of theta. all over cosine squared of theta. Now let's rewrite this. Let's split this up and rewrite it as cosine squared theta over cosine squared theta plus sine squared theta over cosine squared of theta. We know that cosine squared of theta over cosine squared of theta equals 1. And then using our trig identities, we know that sine squared of theta over cosine squared of theta equals tan squared of theta. So we were able to find that the derivative of our original function, sine of theta over cosine of theta, equals 1 plus tangent squared of theta. We also know that sine theta over cosine theta equals tangent theta. So at this point, we also know that the derivative of tangent theta equals 1 plus tangent squared of theta. So this is how we use the quotient rule to be able to solve the derivative of functions that include division. Now I'll leave you all with an example to do on your own. Solve for the derivative of f of x equals e to the x plus 3x all over x plus 5. When you get the answer to this problem, as I know you all will, drop it down in the comments below. If this video was helpful for you, hit the like button and subscribe to our channel. Thank you so much for watching The Numbers Game.